Hello.
Hello, can you hear me?
Excuse me, ma'am. Are you the TA for this course?
Yes.
Okay, ma'am. Actually, like uh, I am a student of IIT Madras, and I'm like following this course along. So I just wanted to know, like, the final examination, will it be online at a center or online from our own places?
I am not very sure of it. Can you please mail it to the NCTA team and they will send you all the details related to the final exam?
Okay, ma'am. Which is the email ID?
Uh, that SWAYAM portal must have some email ID
Okay.
or contact details.
Mm-hmm.
Just put a mail to the NCTA team.
Okay, ma'am.
Okay,
And
and yeah,
ma'am, and any other help? Like, I was very busy with my own coursework this semester. I'm like a second year student.
yeah,
So, if you can give me any advice how to catch up quickly for the final examination.
so for the final examination, I would recommend you go through the problem solving session. All right. The recordings are available on YouTube. You can find
Okay.
them. Okay. There are
Okay.
three TAs for the course. All of us have discussed few problems, and
Mm-hmm.
today also I'll be discussing some more. You feel free to attend if you have time, of course.
Okay,
And
ma'am.
also you can take up any basic textbook and go through their solved examples. That will help you a lot.
Okay, ma'am. Sure. Okay. Because now I'm not sure if I'll have time to see all the lectures. So,
Yeah.
like a book and the solving sessions.
Yeah,
Okay.
there will be quite a few solving sessions. You will find the YouTube links in a document which is shared by the NTTA team. So there are three TAs for this course, and they all of us have discussed few problems.
Okay, ma'am. Where is the link for the YouTube
Can
sessions?
you see my screen? Is
Yes.
my Google screen visible to you?
I can just see PowerPoint.
You can just see PowerPoint. All right, 1 second. Is it visible now?
Yes, ma'am.
Yeah, so once you sign in, just go to your course.
Mm-hmm.
All right, and here you will have this link, problem
Okay.
solving session recording. Click here for the problem solving lectures. Here you will have the YouTube links, and here you would have the folder drives uh, where you would have access to the entire folder. So I can open mine and show you. So here you would have all the slides and the solutions of the problems discussed. So
Okay. Thank you
whatever
so much,
difficult,
ma'am.
you can go to this link, and you can also check out the other links. They would also have discussed some problems, but it is recommended that you at least try to go through the lectures maybe in 2x speed or something, because that will
Okay.
help you gain some concept, because these are just examples and you might get something very basic for which you need very basic knowledge. If time permits, just go through the lectures in 2x speed if you can.
Okay, ma'am. Okay. Thanks very much.
Thank you. Is there any specific question that you want to ask?
Sorry, ma'am. You were saying something.
Yeah, I was just asking, is there any specific question which you would want to ask?
Ma'am, I have not yet seen week 12's lectures, so I have to like do that. I don't want to waste your time, so I'll leave.
Okay, from the other previous week, is it
No, ma'am. Nothing right now.
nothing right now? All right.
Thank you very much.
Thank you. Okay. So for those of you who would see this video, see a video recording of this lecture. So welcome back to week 12. Today I'll be discussing few problems which were given as assignments to you all, and then how you can tackle these kind of situations and these kind of problems that I'm going to demonstrate. Okay, so week 9 was very easy, but still when I'm discussing I might as well discuss whatever has been done. Okay, so here we have 5 data points and you have been asked to find the median of these 5 data points. Alright, please pardon me because yeah, so we have been given 5 data points: 4, 14, 20, 7, 8 and 10. So step 1 would be to arrange in ascending order. Alright, so we would arrange these in ascending order. So it would be 7, 8, 10, 14 and 20. Okay, and then step 2 would be to see how many numbers are there, odd or even. So here we have 1, 2, 3, 4, 5. So n here is 5. That is odd. So if n is odd, then median is n plus 1 by 2th term in the ordered list. Which is the ordered list? In this case, this one. Okay, so here we have n equal to 5, which is an odd term. So this would be n plus 1 6 by 2, that is the third term in the ordered list. So here third term is which one? 7, 8 and 10. So third term is this one, and that's why the answer is B, 10. Alright, now what happens if we have an even number? Alright, so the next question is this: find the median of a given data where we have 1, 2, 3, 4, 5, 6. So here n equal to 6, that is n is even. So if n is even, then median would be a mean of n by 2th term and n by 2 plus 1th term. Okay, so what I mean by this is n by 2 is 3 and n by, so third and fourth terms mean. Okay, so step 1 again, here we are going to arrange. So it will be 3, 6, 10, 11, 12, 15. So what is the third term? Third term is this one. And what is the fourth term? N by 2, 3 plus 1, that is fourth term is 11. So therefore median is 10 plus 11 by 2, which is 21 by 2, which is equal to 10.5. That's the answer. Option D. Alright. So let's move on to the next one. So here we have, if the largest value of a data set is doubled, then which of the following is false? So mean increases, standard deviation increases, interquartile range remains unchanged, and median increases. So which of this is false? Mean increases because x1, x2 and xn, let this be the uh, set of numbers. So mean would be summation xi by n. Alright. Now let's say x7 is the maximum. Okay. So if x7 is double, then here x bar would be summation of all xi's plus 2 into x7 by n. So this term is going to change. So mean obviously will change. So it's not false, it's true. If mean changes, the standard deviation will also change because standard deviation SD is summation xi minus x bar whole square 1 by n root. Okay, this is the standard deviation formula. So xi is going to change and x bar is going to change. Alright. So then if both of these changes, then the standard deviation will also change and the standard deviation will increase because the variation is going to increase. Let's say we had something like this, starting from here, ending from here. Okay, in between. So let's say this thing is doubled. So now the data set varies across a larger region. So this one, instead of here, it has shifted to, let's say, this point. So then the variation in the data set has also increased, and as a result, the standard deviation has also increased. So this is also true. Interquartile remains uh, unchanged. So interquartile range is how much? Interquartile range means Q3 minus Q1. So if we have a data set like this, if we can divide it into 4 parts, and this one is Q1, this one is Q3. Now the largest one will always be beyond Q3, and so this thing will remain unchanged. Alright, and the fourth one is that the median increases. This is incorrect because median is essentially Q2. Alright, that value of the variable which divides the entire data set equally into two halves. So this median is not going to change if the largest value which was already beyond the median, that is doubled, because it's not shrinking, it is getting doubled. So when we arrange in ascending order, only the last term is going to change. Okay, so let's say for example we have 2, 5, 7, 9 and 13. So here the median is 7 because it's the third observation. Now if 13 is double to 26, then also its position in that ordered list is not changing, and thus it's not affecting the median. So if we are asked that which of the following is false, then option D is false. The median does not increase. Alright. Fine. So question number 4 says that the summary for scores on a statistics exam is this in all. 152 students took the test. How many had scores between 77 and 83? Okay. So summary stat, what it is giving is that 35 is the minimum. Okay. 97 is the maximum. 68 is Q1. 77 is the median, which is Q2. And 83 is the median, it's the third quartile, which is Q3. Alright. So now, how this entire data set, so if I have 152 uh, students, then quartiles divide the data set into 4 parts. So this total would be 152. So 152 by 4 would fall in this range, that is 38. So 38 would fall here, 38 would fall here, 38 would fall here, and the other 38 would fall over here. Alright, so since 77 and 83 is Q2 and Q3, so this is Q1. Hence, between these two values, we would have 38 students. Alright, and here somewhere we would have the maximum, which is 97, and here somewhere we would have the minimum, which is 35. Alright, so answer is 38. Okay, moving on. So suppose a population can be described with a normal distribution with mean 10 and sigma square 2.5, then what is mu? Then in the question, mu is a, so mu and sigma, these are population parameters. Alright. Okay. A survey is conducted of 300 likely voters. The proportion P hat for a particular voter is an example of, so P hat is a statistic. Alright, this is the predicted value. P hat would be determined based on the, so P hat would be some function of the observed variables. Okay, it would be some function of the xi, okay, which are realizations of the random variable x that follows a binomial distribution or follows some distribution, not necessarily binomial. Which follows some distribution. Alright, so function of the observed variables which do not have any unknown parameter, that is known as statistic. Alright, moving on. Now, independent random variable samples of size n1 and n2 are taken from the normal populations, normal mu1 sigma 1 square and normal mu2 sigma 2 square respectively. Then the sampling distribution of the difference between the sample means is given by what? Alright, so here if x follows a normal mu sigma square, then x bar always follows normal mu sigma square by n. Okay, so here let's say x1, x2, xn following normal mu sigma square, then x bar is 1 by n summation xi, I equal to 1 to n. Okay, xi follows normal mu sigma square, then x bar will follow normal mu sigma square by n. This is a result that you should bear in mind. Alright, now what they are saying, and also one more thing is that linear combination of normal variables are normally distributed. Okay, so keeping these 2 points in mind, we would find out what is the sampling distribution of difference between sample means. So let's say we have let x1, x2, xn be one sample and then y1, y2, yn be the other independent sample. Alright, so here what we have two samples, x1, x2, xn following normal mu1 sigma 1 square. So following normal mu1 sigma 1 square. So x bar will follow normal mu1 this is n1, alright, sigma 1 square by n1. Okay, and also we have y1, y2, yn follows in2 following normal mu2 normal mu normal mu2 sigma 2 square. Then y bar will also follow normal mu2 sigma 2 square by n. And to note, this one and this one are independent. Alright. So now if this is true, then we have x bar follows normal mu1 sigma 1 square by n1 and y bar follows normal mu2 sigma 2 square by n2, and these two are independent. So x bar minus y bar, which is what we want, difference between sample means. So that would be x bar minus y bar. This thing is a linear combination of normal variables. Okay, so therefore x bar minus y bar would also, so thus it would also follow a normal distribution. And what will be the mean? So expectation of x bar minus y bar would be expectation of x bar minus expectation of y bar. So that would be mu1 minus mu2. Alright. And what will be the variance? So variance of x bar minus y bar would be variance of x bar plus variance of y bar minus 2 covariance of x bar and y bar. Now xi and yi are independent, which implies x bar and y bar are also independent. Okay, and if it is independent and they are normal variables, so since normal, if x bar and y bar are independent, then the covariance, if independence holds, then covariance between x bar and y bar would be 0. So therefore covariance x bar and y bar equal to 0. Therefore we have variance of x bar minus y bar equal to variance of x bar plus variance of y bar, which is sigma 1 square by n1 plus sigma 2 square by n2. Therefore what is the distribution? Therefore difference of sample means follows normal mu1 minus mu2, which is the expectation, and sigma 1 square by n1 plus sigma 2 square by n2. Alright, and that is the answer. See, this is the answer. This one, option C. Alright. So we'll move on to the next one. So here they are saying the mean of a sampling distribution of S square for a random sample of n from normal population with mean mu and variance sigma square is how much? Alright. Mean of sample distribution of S square for random sample of size n from normal population with mean mu and variance sigma square is how much? So x follows normal, so xi follows normal mu sigma square. S square equal to summation xi minus x bar whole square. Alright, S square is 1 by n minus 1. Alright, now alright, where S square is 1 by n minus 1 summation xi minus x bar whole square. Alright, now let's move on to the next one. So the difference between sample value expected and the estimated parameter value of the parameter is called bias. So if theta is the true parameter, this is equal to theta hat, which is the expected, plus b, which is the bias term. Alright, okay. Then let's move on to the next one. So in a large population of adults, mean IQ is 110 with standard deviation of 30. Suppose 100 adults were randomly selected for a market research design. The distribution of sample mean of IQ is how much? Okay, so we had x1, x2 and x100 from, let's say, let us assume that IQ follow a normal distribution with mean equal to 110 and sigma equal to 30. Alright, so this follows mu sigma square. Point to be noted, sigma is 30. Alright, now then x bar, this will follow normal mu sigma square by 100. So then variance would be sigma square, that is 900 by 100, that is 3. Alright, so that is 900 by 3 is, sorry, not 3, that is 9. Therefore x bar follows a normal with mu equal to, mu remains the same, 110, and SD sigma equal to root over 9, that is sigma equal to 3. So the answer is this one, B, approximately normal with mean 110 and standard deviation 3. Alright, if we would have been given something like exactly normal, then also we should select this. I feel we should select this approximately normal, because firstly we are assuming this to follow a normal distribution. Okay, here we are making some assumptions. If they are stating that it's from a normal distribution right away, then we can directly go ahead and say that it's exactly normal. Alright, so that was all about week 9, and let us proceed to week 10. Alright, so the question is, a mayonnaise producer claims that the mean weight of mayonnaise in a jar is 230 grams. A random sample of 8 jars is selected and the weight of mayonnaise in each jar is determined. The result in grams are 220, 228, 232, 219, 221, 223, 230, 229. Assuming that the weight of mayonnaise in a jar is normally distributed, test at the 5% level of significance the mayonnaise producers claim. So what was their claim? Claim was H naught was that the mu is equal to 230 versus H1 is mu not equal to 230. So the thing is, firstly we'll write it in this manner. Let x1, x2, xn, or rather let us write in this manner. Let xi equal to weight of mayo in ith jar. Okay, xi follows some normal mu and sigma square. Alright, now sigma square they are not given. So the claim is H naught is mu equal to 230 versus H1 is mu not equal to 230. So for this case, when sigma is unknown, the test statistic is x bar minus 230 by the SD. Okay, and this will follow under H naught, it will follow a T n minus 1 distribution. So we would reject H naught if and only if this is my T, that is the test statistic. We reject H naught if and only if T observed, mod of T observed is greater than Tn minus 1, 0.025. Alright, so what we mean is this. So we'll calculate everything one by one. Okay, so the test statistic is x bar minus 230 by SD is 1 by n summation xi minus x bar whole square and root. Alright, so x bar is how much? X bar is this thing, 220 plus 228 plus 220 plus 228 plus 232 plus 219 plus 221 plus 223 plus 230 plus 229 divided by 8. How much do we get this? Sorry, I wrote it SD here. Here I should write. So here, this is the test statistic is x bar minus 230 by s by root n. This is actually the t statistic. Sorry, x bar minus, because we are taking x bar. Okay, and s is how much? S is n minus 1. So x bar will be 220 plus 228 plus 232 plus 219 plus 221 plus 223 plus 230 plus 229 divided by 8. So this is something around 225.25. So T observed will be 225.25 minus 230 divided by root over 1 by 7 summation of this minus this whole square. So this will be how much? This will be this will be plus 221 minus 225.25 whole square plus 223 minus 25.25 whole square plus 230 minus 225.25 whole square plus 29 minus 225.25 whole square. This is 186. Okay, so 186 divided by 7 is 26.57. So square root of square root of divided by 7, which was 5 point something. So this was something around 225.25 minus 230 by 5.15 something. So this would be 225.25 minus 230 divided by 5.15. So this is something minus 0.922. Alright. So my rejection rule was how much? My rejection rule was we would reject H naught if and only if modulus of the T observed is greater than Tn minus 1 0.025, because it's a two-way tail. So let's say this is my T distribution. So if this is a point Tn minus 1 0.025 such that the area above this point is 0.025 and the area This is a symmetric distribution about 0. So this would be minus Tn minus 1, 0.025. So the area below it would also be 0.025, and together they would make up 0.05, which would form the 5% level of significance that we want. Alright? Okay. So then our task is to find out this thing. So how would we find this out? So for this we need a T table. Sorry. T distribution table. Alright. So let's say this is my T table. Probability 2 tails. Alright. So probability 2 tails, we want this one. 0.025, and the DF is what? DF is degrees of freedom. So here our degrees of freedom is 7. So what the answer is we want is 2.365. Alright. So this value, where is it? This is 2.365. Alright. So here this I think I made some calculation errors. So here they are saying it is rejecting 8 not at 5% level of significance. Mayonnaise fractions claim. Yeah, x bar minus 230 by s by root 10 follows a t n minus 1 distribution. Here we have 8, not mistaken, 1, 2, 3, 4, 5, 6, 7, 8. Yes, 8 only. Maybe here I made some mistake. Okay, we'll find out. Let's see. Oh, I see where we've made the mistake. Yeah. Here you see I've written only s. This we have to divide s by root 10. So this one divided by root over 8. Alright, so this one into root over 8. We would have something into root 8. So minus 0.922 into root 8 would be how much? Into root over 8. This is minus 2.608. And this is how much? 2.635. So here what do we have? We have our T observed equal to minus 2.608, and the cutoff or T n minus 1 0.025 is 2.365. So since T observed mod equal to 2.608 is greater than 2.365, therefore we reject H naught against H1 at 5% level of significance. Alright, you understood where I made the mistake here. This is the test statistic is T equal to x bar minus mu under H naught by S by root n. This is the test statistic. And I made a mistake of missing out n. So you don't make a similar mistake. You follow this thing. And S is square root of 1 by n minus 1 summation x I minus x bar whole square. Alright. So thus we reject our null hypothesis and conclude that mean weight of mayonnaise is not 230. Alright. So let us move on to the next one now. Okay. The test statistic for a two-sided significance test for a population is z equal to minus 2.12. What is the corresponding p-value? So p-value for a two-sided test is probability mod t greater than t, which is equal to probability t greater than t plus probability t less than minus t. Okay, so this t is 2.12. Alright, so modulus of t greater than 2.12, this would be, so here we would write this as the p-value would be probability z greater than 2.12 plus probability z less than minus 2.12. So let us find out the standard normal table. Okay, so P, this is So probability, whatever we have, probability z less than minus 2.12 would be minus 2.12, no? So 2.1, let's say here, minus 2.12. It is 0.01321. So this is 0.01321. And this one, probability z greater than 2.12, is 1 minus 2.12, that is this one, 0.983. 1 minus 0.983. So this will be how much? 1 minus 0.983. 1 minus 0.983 is 0.017 plus 0.01321. So plus 0.01321. This is something 0.03021. So the closest answer is 0.034. Alright. Now let us move on to the next one. So a car manufacturer claims that the average fuel efficiency of a certain model is 40 miles per gallon. You calculate a sample of 25 cars and find that average fuel efficiency is 38 mpg with a standard deviation of 3 mpg. Perform a hypothesis test to determine what is the correct answer. Okay. So claim let xi is, let xi denote fuel efficiency of ith car. So we have a sample of x1, x2, x25. X bar we have calculated, which is 38, and S we have calculated is 3. This is the sample S. Okay. So similarly, H naught was mu equal to 40. So then test statistic would was x bar minus 40 by S by root 25. Okay, which under H naught would follow a T24 distribution. So let us find the value of the test statistic. So say then T observed is x bar minus 40 by S by root 25. That is how much x bar we have calculated. X bar we have calculated to be 38 minus 40 by S we have calculated as S we have calculated as 3. So here would be 3 by 5. So here we would have minus 2 into 5 minus 10 by 3 minus 3.33. This is the T observed. Performed if so our claim is H1 is mu not equal to 40. Therefore, we will reject H0 if and only if mod of T observed is greater than T24 0.025. So same thing, we'll go to the T table, find out this one 0.0252 tail, 0 or 0.0251 tail, and we'll go down to DF24. So that is 2.064. Alright. So this one is so T24 0.025 is 2.064. So as per this thing, we should reject H naught at 5% level of significance. Now the thing is, here if it depends on how the standard deviation is calculated. So sample standard deviation, what is usually means is 1 by n minus 1 summation xi minus x bar whole square and square root of that. But if they have used this formula for SD, then we have to adjust S equal to 3 into 4 by 5. That would be 2.5. In that case, we would have minus 2 by 2.5 by 5, which is equal to minus 2 by 0.5 to equal to minus 10 by 2.5, which is equal to 4, minus 4. Then also it is rejecting only. 2.4 it would become then. Become 2.4. Then we would have had that equal to by 2.4 minus 10 by 2.4 minus 10 divided by 2.4. Anyway, we'll come back to this one. So according to this thing, it should have been reject the null hypothesis. Okay, so this would have been reject null hypothesis at 5% level of significance. So here we have x bar equal to 38, s equal to 3, and this would be 20. This is 38 only, right? Alright, let's move on to the next one. A random sample of 20 observations. A random sample of 20 observations produced a sample mean of x bar and s equal to 25.8. What is the value of the standard error of x bar? So standard error of x bar was s by root 10 equal to 25.8 divided by 19 by 20 by root over 20. Okay, so this would be s by root 10. So a random sample of 20 observation produced a sample mean So the question is a random sample of 20 observations produced a sample mean of this much and s equal to 0. What is the standard error of x bar? So standard error of x bar would be s by root over n, which is 25.8 divided by root over 20. So that would be 20.8 divided by root over 20, which is equal to 5.76, close to 5.8. That is the answer. Alright. Alright. So then let us move on to the next one. Anisha believes that 50% of brides in India are younger than their grooms. Performs a hypothesis test to determine if percentage is the same or different from 50. Okay, Anisha samples 100 brides. 53 reply that they are younger than their grooms. Okay, so the hypothesis is H naught is, she believes that let this be probability brides age less than, or rather let us say let let us formulate the process in this manner. So let xi equal to 1 if bride of if bride's age is bride i's age is less than, or if bride i's age is less than groom i's age, and 0 otherwise. Okay, so probability xi equal to 1 is the p that she is looking for, and her h naught is p equal to 0.5 versus h1 is p great. So she performs a hypothesis to determine if the percentage is same or different from 50%. So that even though here the confusing thing is, even though she believes this is thing, the test she is performing is percentage is same or different. Same or different means P not equal to 0.5. So thus in this kind of situation a two-tailed test is appropriate. Alright, because if she wants to test if the percentage differs from 50%. If she would have wanted to believe that this is higher, this percentage is greater than 50%, or this is less than 50%, then that would have been the alternative hypothesis, P greater than or P less than. But she just wants to say if this P is same or different from 50. So that's why a two-tailed test is appropriate in this scenario. Alright, let us move on to the next one. To perform a one sample t-test using the following statistic: n equal to 5, x bar equal to this, s equal to this, null hypothesis is mu equal to 5. Alright, so then one sample t-test, the t is x bar minus mu by s by root 10. So here this is 3.871 minus 5 by 0.679 by root 5. This is how much? 3.871 minus 5 divided by root 5 divided by 0.679. So this is minus 0.74. Okay, and t n minus 1 4 0.025 is how much? This one, 2.776. So this is 2.776. Let us, I think there's a problem with this t table. Let me just look at this one. Or this one. Areas in the upper tail are given along the top table. So this probability is given over here. So if I have 0.025 t, this is 2.776. Yeah, same thing only. So this is a two-tailed test. Tn minus 1 0.025 3.871 minus 5 divided by root over 5. Here I've made a mistake. Sorry. This will be this is divided by 5, no? So here, this is the problem. Okay, 3.871 minus 5 by this one. So this would be 3.871 minus 5 into root 5 divided by 0.679. So this is minus 3. Now it is minus 3.717. Alright, and T4 0.025 is as I said, from this table. So from this table 0.025, this is 2.776. So since T observed, mod of T observed is greater than T4 0.0025, that is rejected at 5% level of significance. Alright, but what happens at 1%? 1% level of significance means the cutoff for T is going to change. So this is 5% level of significance cutoff. At 1% level of significance, we would test T for 0.005. Alright, that is 0.005 is 4.605. So this is 4.605. Okay. For this situation, mod of T observed is less than T for 0.005. That is 1%. Alright. So this is accepted at 1%. Alright. Okay. So I think in the previous one also I made the same mistake. Here. No, here also I was doing the same thing. Maybe something else. Alright. Let us move on to this one. The rejection probability of null hypothesis, when it is true, it is called level of significance. Okay. Okay, based on the information, okay, one sample T statistic from a sample or n equal to 19 observations for the two-sided test of H naught, mu equal to 6 against mu not equal to 6 has a T value 1.93. Okay. So one sample T test. So the cutoff is T n minus 1, that is 18, and then the level of significance alpha by 2. Alright. So we have to find out T18 0.1 by 2, that is T18 0.05. So that would be T18 0.05 is 1.734. This is 1.734. So this value T observed is exceeding this cutoff. So mod T observed exceeding Tn minus 1 0. Alpha by 2. Therefore, we are going to reject at alpha. So this would be, we would reject null hypothesis at alpha. And if p value is less than 0.05, we are also going to reject. But not like this. It should not fall within any category. Alright. So the correct answer is option number 1. Okay. Consider a hypothesis H0 where theta not equal to 5 against H1, theta 1 greater than 5. This tail is right tail. Alright. Next one. The researcher claims that the proportion of people who prefer band A over band B is at least 60%. In a sample of 200 individuals, one third 150 express a preference for brand A, conduct a hypothesis test at 1% significance level to determine if there is enough evidence to support the researcher's claim. Okay. So a researcher claims that proportion of people who prefer brand A over B is at least 60%. So let xi equal to 1 if ith person prefers A over B. Okay. Pi equal to probability xi equal to 1, which is equal to, and h naught is Pi equal to 0.6 and h1 is, he claims that is at least 60%, that is greater than p greater than 0.6. Alright, so what is the value of the test statistic? Okay, so the researcher has sampled 200 individuals and 130 expressed preference for brand A. So P hat equals to 130 by 200. That is 0.65. Alright, 130 by 200, 0.65. So the test statistic in this case to test for such proportion is P hat minus PH naught by PH naught into 1 minus PH naught by N root over. So here we have P hat was 0.65 minus 0.6 by root over 0.6 into 0.4 by 200. So this would be 0.65 minus 0.6 divided by square root of 0.6 into 0.4 divided by 200. So this one is 1.44. Okay, so let us move on to the next one. Maybe I've done some calculation. Okay, the goodness of fit of a distribution is tested by a chi-square test. Alright, so for this exercise, this question, I'll just look into this once more. This is sorted. This question number 3, week 10, question 3, and week 10, question 10. I'm going to take a look one more time, and then I'm going to and I'll get back to you. Fine. So now that we have discussed week 10 solutions, let us go to week 11 solutions. Okay. All right. So let x1 and xn, let x1 to xn be a random sample from the PDF fx theta, theta x to the power minus 2, 0 less than theta less than equal to x less than infinity. Find the maximum likelihood estimate of theta. So x1, x2, xn is a sample from this thing. So we can write fx given theta as theta by x square into indicator function of x or theta less than equal to xi or x, where I theta less than equal to x is an indicator which is 1 when theta less than equal to x and 0 otherwise. Alright, now to find the maximum likelihood we have to find product of, or sorry, we have to find the joint distribution. Okay, so to find the MLE we need to find the joint distribution of x1, x2 and xn. So if x1, x2, xn, this is essentially product of fxi, because since xi's are, they have said it's a random sample, so they are IID. Alright, so then we can write this product fxi as theta to the power n product 1 by xi square I theta less than x1 into indicator theta less than x2 into indicator theta less than xn. Okay, so this is equal to theta to the power n product of I equal to 1 to n 1 by xi square indicator of theta less than the first order statistic, or in other words theta to the power n product I equal to 1 to n 1 by xi square indicator of theta less than minimum of xi, because only if either of the xi's become less than theta, then the entire likelihood will be equal to 0. But we want to maximize, uh, so since all are greater than theta, then the minimum should also be greater than theta. So we can write it in this manner. Now the MLE is minimum of xi, and why so? So from here we can conclude that MLE is of theta is minimum of xi. Why is it so? Because first thing is there are no value. If it is, I mean, first thing is that all the xi's should be greater than theta. So the minimum, if it is greater than theta, then it is ensured that all the xi's are greater than theta. That's point number one. Point number two is that there is no way to determine whether if there is anything which can estimate theta better and increase the likelihood other than minimum of xi, because that is the sample set that we have at our hand. Estimation will always be from the sample that we have in our hand. So if we take minimum of xi, then the likelihood is maximized, because anything uh, and then it is ensured that the likelihood is maximized in this case, because this product xi, it's fine, but if the minimum is greater, then all indicator functions will be 1 and we would have obtained this sort of thing. Alright, so the MLE of theta is minimum of xi. Alright, we'll move on to the next one. So x1, x2, xn, we are random sample from the PDF this thing. Find the method of moments estimator of theta. So f of x given theta is theta x to the power minus 2, theta less than equal to x, less than 0, less than infinity. Alright, the expectation of x is theta x by x square integration of 0 to infinity. Alright, so this would be theta integration of 0 to infinity 1 by x dx. Now this is an improper integral, because this would be log x and log x at infinity doesn't exist. So expectation of x will not exist. So expectation of x, not x bar, here by mistake I put a bar. So expectation of x does not exist in this situation. Therefore, method of moments estimator, it does not exist. So here we have a random sample from the PDF theta x to the power theta minus 1, where x can go from 0 to 1 and theta can range from 0 to infinity. Alright, so here first thing is to write down the likelihood. So the likelihood would be nothing but likelihood theta given x, we can write it as f of x1, x2, xn. Okay, so this would be, since it's a random sample, it's IID, it would be theta to the power n xi to the power product of xi to the power theta minus 1. Step 2, this is step 1. Step 2 would be take a log likelihood. Okay, so that would be log of theta to the power n plus log of product xi theta minus 1. Alright, so here that is equal to n log theta plus log of product is summation log of xi theta minus 1. So this one is n log theta plus summation theta minus 1 log of xi. Okay, so that thing we can write it as equal to n log theta plus theta summation log xi minus summation log xi. Okay, now step 3, would be to differentiate the likelihood to 0 and solve for theta. So then they would have d d theta of n log theta plus theta summation log xi minus summation log xi equal to 0. So that would mean n by theta plus summation log xi equal to 0. So which implies theta equal to minus n by summation log xi. This is the theta at ML. Alright. Okay. So if xi is a Bernoulli random variable with parameter p, then p hat is the maximum likelihood estimator. Is MLE the unbiased estimator of p hat? Say true or false. So is expectation of p hat, if it is equal to p, then we would say it is an unbiased estimator. So expectation of p hat is how much? 1 by n, expectation of 1 by n summation xi, which is equal to 1 by n summation of expectation of xi. Xi follows Bernoulli p. So expectation of xi would be p, 1 by n summation I of p. This is p, and thus it is unbiased. So the answer is true. Alright. Okay. Alright. Which distribution is used to find the confidence interval for population variance? So this one, if you remember, this thing is chi-square n minus 1. So this is the distribution of population variance. So a chi-square distribution would be used to determine the confidence interval of this thing, okay, for population variance. Breaking strength of cotton gave a mean of 7.4 and standard deviation of 1.2 grams. Find the 95% confidence limit for the mean breaking strength of cotton thread. Alright. So let x denote the xi denote strength of ith cotton thread. Okay. So we assume xi follows normal, sum mu and sigma square. Alright. So here 95% confidence limit for the mean breaking length. So x bar would follow normal mu sigma square by n. Alright. So then we can write probability, which implies x bar minus mu by sigma by root 10 follows normal 0 1. Alright. So then we know that this the area between minus 1.16 and 1.9, sorry, minus 1.96 and 1.96 is approximately 95%. So here we are going to put this sigma by root n. Okay. Alright. Then we can write probability minus 1.96 into sigma hat by root 10 x bar minus 1.96 into sigma by root 10 less than equal to mu less than equal to x bar plus 1.96 sigma by root 10. Therefore 95% Ci for mu for mean strength is given by x bar minus 1.96 sigma hat by root 10 x bar minus 1.96 sigma hat by root n. So here we are going to substitute the values and then that would give us the result. So that would be, here we had 7.4 minus 1.96 into sigma, what we had, sigma estimate 1.2 by root 100 and 7.4 plus 1.96 into 1.2 by root 100. So this would be 7.4 minus 1.96 into 1.2 divided by 10, 0.316, and 7.4 plus 0.316. This would be 7.4 minus 0.316. Sorry, 1.96 into 1.2 divided by 10 was 0.23. Sorry. This will be minus 0.2352. So this one was 7.4 minus 0.2352. So this is 7.1648 to 7.6352. So this is the answer. 7.1652 to 7.635. Alright. So let us move on to the next one. Alright. Let us move on to the next one. The mean lifetime of a sample of 169 light bulbs found to be 1350 hours with a standard deviation of 100 hours. Establish 90% confidence limits with which mean lifetime of light bulbs is expected to lie. Okay, moving on. We have a similar problem. Suppose a student measuring boiling temperature of certain liquid observes the readings in degrees Celsius on 6 different samples. He calculates sample mean. He knows that the standard deviation is 1.2. What is the interval estimation of population mean and 95% confidence level? So now we know what is it. My x bar plus minus 1.96 sigma by root n. So just we have to populate. X bar is 101.82 and sigma is 1.2. And n is how many? 1, 2, 3, 4, 5, 6. So just calculate. This is 1.96 into 1.2 divided by root over 6. This plus 101.82. So this upper limit is 102.7 0.78. Okay, and the lower limit is 100.859. Lower limit is 100.859, so it is 100.86. So answer is 100.86, 102.7. Alright. Similarly, this one, mean lifetime of a sample of light bulbs found to be 1350 hours with a standard deviation of 100 hours. Establish 90% confidence limits. So 90% confidence limits, then the value will change. So let us denote this to be a lifetime and let it follow normal mu sigma square, assume. Then we would have x bar minus plus minus 1.64 sigma by root 10. So that would be 1350 plus minus 1.64 into 100 by root 169. That is 13. That is 1350 plus minus 1.64 into 100 by 13. That would be so the upper limit is then 1362.65 and lower limit is 1337.38. So this one is the close thing. Alright, 1337.352 to 1362.65. Alright, so that was all for today. I hope to see you all in the next session. Thank you.